Welcome to our channel, where we explore the cutting-edge world of healthcare, robotics. Today we're diving into an exciting and practical project, designing a robot for physical therapy. This guide will help you understand how to create a robot, making physical therapy more effective, recovery journey, and accessible. Physical therapy is crucial for patients recovering from injuries, surgeries, or managing chronic conditions. However, access to quality physical therapy can be limited, especially in remote areas. This is where robotics steps in, offering innovative solutions to bridge this gap. Our goal today is to design a robot that can support various physical therapy exercises, ensuring precise movements and consistent support. This robot will be particularly beneficial for repetitive exercises that patients need to perform regularly. First, let's discuss the essential components of our physical therapy robot. The core parts include actuators for movement, sensors for feedback, and a control system to manage the robot's actions. Actuators like servo motors will enable the robot to move joints and limbs accurately. Sensors, such as force sensors and accelerometers, will provide real-time data on the patient's performance and the robot's movements. Moving on to the design phase, we will create a detailed blueprint of our robot, focusing on ergonomic design to ensure it can accommodate exercises the robot will assist with, such as range of motion exercises and strength training and balance exercises. Once the design is ready, we'll dive into the building phase. We'll assemble the frame, install the actuators and sensors, and integrate the control system. This step-by-step process will ensure that our robot is both functional and reliable. After building the robot, we'll focus on programming. The control system will be programmed to guide the robot through various exercises, adjusting movements based on sensor feedback. We'll use an intuitive interface so that physical therapists can easily customize the therapy sessions according to each patient's needs. Testing is a critical part of our process. We'll conduct thorough tests to ensure the robot performs exercises accurately and safely. We'll also seek feedback from physical therapists to refine the robot's functions and improve its effectiveness. Finally, we'll discuss the potential impact of this physical therapy robot. By providing consistent and precise support, the robot can help patients recover faster, reduce the burden on physical therapists, and make quality physical therapy more accessible. That's it for today's practical guide on designing a robot for physical therapy. Don't forget to like, share, and subscribe for more exciting content on healthcare innovation. See you in the next video. Zero physical therapy, medicine, healthcare, AI.